Hello friends, welcome to Engineering Funda family. In this video, I'm going to explain you wraparound time and lifetime in TCP segment header. If you have seen my last videos based on TCP segment header, in that I have explained you how port addressing is happening in source and destination, as well as I have explained you how sequence number and acknowledgement number is there in TCP segment header. In video of sequence number, I have explained you how wraparound condition is happening. If you have seen my last video, in that I have explained how wraparound is happening in sequence number. So for wraparound, whatever time is required, that is wraparound time. Now, as if you want to calculate what is wraparound time, then simply you can say for 4 GB data transmission, for 4 GB data transmission, whatever time is required, that is wraparound in TCP segment header. But you need to know like how it is 4 GB. See here, as if I say we are having transmitter over here, right, and here we are having receiver. Now in between transmitter and receiver, obviously there will be frame transmission. Let us say we are starting frame transmission over here. It is having sequence number 0. Then we are forwarding frames in sequence. Let us say here we are having 100 sequence number, here we are having 1000 sequence number, and we will be keeps on sending frames over here with sequence number mentioned over here. After completion of all the sequence number, it is always possible that you will have to reuse sequence number, right? You will have to reuse sequence number. Let us say we have completed all the numbers as per 32 bits. Again, I am sending with sequence number 0. So if you observe here, from 0 to 0, whatever time that we have for transmission, that is wraparound. The reason is again we need to reuse sequence number. And here, how much sequence number that is possible? 32 bits. So as per 32 bits, how much data that I can forward over here? 2 to the power 32 means 4 GB. Right, 2 to the power 32 means 4 GB. So wraparound time, that is a time which is there for 4 GB data transmission in TCP segment header. Right, means in wraparound again you will be reusing sequence number. Sequence number is having size of 32 bits. That's why wraparound time, that is a time for 4 GB data transmission in TCP segment. Right. Now, there is one more interesting concept, that is lifetime. And here why I am explaining you these definitions, the reason is you need to understand what are the critical situations and how those critical situations are handled in TCP segment header. Right. So here lifetime, that is a time in which packet may be there on computer network. Means packet cannot be there on computer network for more than lifetime. Lifetime is a maximum time for packet, and for that much time only that packet can be there on the computer network. After that, that packet will get discarded. Right. Typically it is 180 seconds right now in 2023. Obviously it will be going to decrease in future, but in 2023 typically it is 180 seconds. Now you might be thinking like why we are just discussing this definition. See, we are just discussing this definition. The reason is you need to understand how many issues are possible, right? So that I'll explain you by example. So let me consider first example. See, bandwidth is 1 Mbps. Typically this bandwidth that almost everybody is using right now, in more than this that people are using nowadays, right? So as if bandwidth is 1 Mbps and as if lifetime is 180 seconds, and we are ignoring headers, right? Then what will happen? You see here, what will be wrap up time? Here wrap up time, that will be data divided by bandwidth, right? Data divided by bandwidth. So here, see, wrap up time data will be 4 GB. So here 4 GB data will be there, divided by bandwidth is 1 Mbps, right? So 4 into 2 to the power 30, G means 30, divided by 1 into MB means 2 to the power 20. So you can say 4 into 2 to the power 10. So 2 to the power 10 is 1024 into 4, that will be 4096 seconds. So here we are having wrap up time, that is 4096. If you observe lifetime over here, so lifetime that is given 180 seconds. So here wrap up time that is way greater than lifetime over here. So there will be no issue in data transmission. Why? The reason is wrap up time that is greater than lifetime. You see why there cannot be any issue. See here we are sending frame with sequence number 0. Then we are forwarding sequence number 100, 1000 like this, right? And again we are reusing sequence number 0 onwards. Let us say this frame, is getting delayed somewhere. Then it can get delayed by how much time? Lifetime. It cannot get delayed more than lifetime, right? So here wrap up time, here if you see we have calculated that is 4096, but lifetime is 180 second only. So even if this frame is getting delayed to have reception at receiver side, there will be no issue, as wrap up time that is 4096 seconds. So 0th frame that is getting started from here onwards, right? So in this situation there will be no issue, but there can be issue if bandwidth is more. Let me explain you how. See here bandwidth is 1 Gbps. Nowadays in 2023 many people are using this bandwidth. Right now even I am using bandwidth which is more than 1 Gbps, right? So for this let me calculate wrap up time. So wrap up time that is data divided by bandwidth. Now data is 4 GB and bandwidth that is 1 Gbps, right? So this is 4 seconds. And if you talk about lifetime, then you see lifetime is 180 seconds, right? So here what is happening, you see here wrap up time that is lower than lifetime. So in this situation there can be issue, right? Practically we are using 1 Gbps speed and lifetime is 180 seconds. So obviously there is a possibility of issue. Let me explain you what could be the issue. See here if you observe, this is what zeroth sequence number frame. Now wrap up time that is 4 seconds. But lifetime for this frame that is 180 seconds. So it is always possible that if this frame is getting stuck somewhere in other routers, and if it is received at receiver by some delay, let us say we are not receiving that over here, we are receiving that somewhere over here with sequence number 0, right? Then what will happen? Wrap up time that is 4 seconds as per this speed, but lifetime that is more than 4 seconds, means after 180 seconds also it is possible that receiver will be receiving this frame with sequence number 0. So there can be false reception. The reason is already 0 frame that is forwarded over here, but this frame is getting received over here by some delay, and as lifetime is more than wrap up time, there is always this possibility, and because of that there can be conflict of data, right? But that is not happening right now in this world. See, even we are having this bandwidth which is even way greater than this. Still this lifetime is 180 seconds, but this issue is not happening. Why that issue is not happening? Let me explain you how. If you observe this TCP segment header, so in TCP segment header we are having this option field, and in this option field, if lifetime is greater than wrap up time, in that situation this option field that is getting utilized, and in this additional bits that we are using along with sequence number, and those additional bits in option that is referred as timestamp. Let me explain you how. See here this issue is getting arised because of we are having limited sequence number, right? 2 to the power 32, up to that only sequence number is possible. But if you increase sequence number, then you will be increasing wrap up time, and by increasing in that sense, what you can do is you can make wrap up time greater than lifetime, and that we are doing it by using option field. Like you see how we can use option field over here. See, we are having how many bits in sequence number? In sequence number we are having 32 bits, right? And because of 32 bits wrap up time, wrap up time is how much? Wrap up time that is 4 seconds, right? Wrap up time that is 4 seconds. Now if I want to increase wrap up time, beyond 180 second, then what can I do? I need to increase data size. Data size cannot be increased, right? It is 4 GB only. So what I can do is I can increase number of bits. You see, number of bits over here, with sequence number, that is 32. But with the use of option field, if I increase bits, right, and that bits will be sequence number of bits plus option, right? Sequence number bits plus option. So what will happen? 32 plus some bits, right? Now if I say here I am using option bits as 8, so what will happen? This is 40 bits, this is 40 bits. So with 40 bits, how much data size will be there? With 40 bits, data size will be 1 terabyte. So here data size, that will be 1 terabyte. Now you see what will happen. So now your wrap up time, that will be, as per 40 bits, I am writing 2 to the power 40 over here, and bandwidth, that is 1 Gbps, right? 1 Gbps means 2 to the power 30. So this will be 2 to the power, 10. So that is 1024 seconds. So now you see wrap up time is 1024 seconds, which is greater than lifetime, and that is how we are resolving this issue, right? So here what we do is, practically what we do is, to avoid issue, we are using option field, in which we are using option field as timestamp with sequence number, right? So you can say here we are having sequence number, right? Along with that, we are using option field, So here sequence number size, that is 32 bits, and this option field that we are using as timestamp means we are increasing total bits, and based on that we are increasing total size of data, and as we are increasing total size of data, wrap up time, that is getting increased. And as wrap up time is getting increased, what is happening? The issue of this data conflict, that we can resolve, right? So practically, if you observe here, by using this option field as timestamp, we avoid the issue of wrap up to life, right? Wrap up to life issue that is so common nowadays, and that could be easily resolved by this option field which is there in TCP segment header, right? That's why you need to understand each and every field so carefully, and then you can easily solve any question in any competitive examination. I hope you have understood this. Still, if anything that you would like to explain, please note it down in comment section. I'll be happy to help you. Thank you so much for watching this video.